Have you ever actually stopped to think about the crazy, complex plumbing system hidden right inside your head and neck? Welcome to The Explainer. Today we're unpacking a topic that is absolutely essential for our daily survival, but honestly, it's almost always overlooked. We are going to break down salivary glands anatomy.
Okay, let's dive right into this with a pretty wild question for you. What exactly produces up to 1.5 liters of fluid in your mouth every single day? That's roughly the equivalent of 3 whole standard water bottles. The answer, of course, is your salivary glands. And while this fluid is about 99.5% water, it's that remaining 0.5% that performs absolute magic for your body.
Seriously, saliva has some secret powers. Without it, you literally couldn't swallow properly because it moistens and lubricates your food. But it goes way beyond just that. It actually buffers your oral pH to neutralize bacterial acid, which completely protects your teeth from decay. It also packs things like lactoferrins and immunoglobulins to defend you against infections. But here is my absolute favorite part. It contains enzymes like amylase that act just like tiny chemical scissors. They initiate the breakdown of carbohydrates right there in your mouth before the food even hits your stomach.
So how is all this fluid actually generated? Well, let's take a top-down visual tour. What we're looking at here is a beautifully clear 3D model of the lower jaw or mandible, highlighting the big 3 major salivary glands. Now, while you do have hundreds of tiny minor glands scattered all around your mouth, these major ones, they're the heavy-duty pumps in your anatomical plumbing network. In fact, they're responsible for producing a staggering 90 to 95% of your total saliva.
All right, let's meet the first main character of our breakdown. Number 1, the absolute heavyweight of the group, the parotid gland. The parotid gland is by far the largest of all the salivary glands, weighing up to 30 grams. If you look closely, you'll notice how it sits right in the preauricular area. Basically, that means it's literally just in front of your external ear, sliding right on down towards the angle of your jaw. It has this sort of inverted pyramid shape to it. You know when you smell your absolute favorite food and your mouth just suddenly waters? Yeah, you have the parotid gland to thank for that. It produces about 60 to 65% of your stimulated, watery, serous saliva. Now, here's where it gets really interesting. Notice the sheer complexity of this structure. The parotid gland isn't just one solid block of tissue. It's actually composed of 2 distinct lobes. You've got a superficial lobe on the outside and a deep lobe right on the inside. But what exactly separates them? Well, it's the facial nerve, also known as cranial nerve 7, which you can see passing right through the middle. This is incredibly important surgically. If a doctor has to operate on the parotid gland, they have to carefully navigate around this major nerve that controls all your facial expressions just to avoid causing paralysis.
Okay, so the parotid gland produces all this saliva, right? But how does it actually get from there into your mouth? Well, that is exactly the job of Stenson's duct. This is the 7-centimeter primary excretory duct of the parotid gland. I like to think of it as the main pipe carrying water directly from the pumping station straight to your house.
See that bright green line crossing the cheek? That right there is Stenson's duct. It travels horizontally right over the top of your masseter muscle, which, by the way, is the main muscle you use to chew. From there, it takes a sharp inward turn, literally pierces right through your cheek muscle, and enters the oral cavity right opposite your second upper molar tooth. Actually, if you run your tongue along the inside of your cheek, right near your upper back teeth, you might even feel the tiny little bump where it empties.
Moving right along, we come to our second key structure. Number 2, the main producer of your daily resting saliva, the submandibular gland.
Tucked right underneath the lower jawbone is what we call the submandibular triangle. The gland itself is roughly the shape of a U, or a horseshoe. Now, while the parotid gland goes into total overdrive when you're eating, the submandibular gland is really your baseline workhorse. When you're just sitting around, not eating, this gland is quietly pumping out a massive 70% of your daily saliva just to keep your mouth perfectly lubricated. Now, what's really interesting about this slide is the unique way this gland is positioned. Much like the parotid, it also has a superficial and a deep lobe. But look at exactly how they connect. Do you see the muscle running right through the middle? That's the mylohyoid muscle, which basically forms the floor of your mouth. The submandibular gland physically wraps right around the posterior edge of this muscle, kind of like a hook or the letter C. It's just a fantastic piece of anatomical packaging.
Just like our first gland, this one needs a pipe too. Enter Wharton's duct. This is the central excretory duct of the submandibular gland, measuring in at about 5 centimeters, or just about 2 inches in length.
Let's trace Wharton's duct for a second. The green line shows it traveling forward along the floor of the mouth, finally draining right under your tongue at this tiny little bump called the sublingual caruncle. But look really closely at the yellow line crossing right underneath it. That is the lingual nerve. This is a massive point of clinical relevance, because the nerve that literally gives sensation to your tongue crosses right under the duct. So during neck or jaw surgeries, surgeons have to treat this delicate crossing zone with extreme caution just to protect your sense of touch and taste.
This part is often misunderstood, so let's pause for a second and really contrast the two major players we've covered so far. The parotid is the largest physically, right? But it primarily tags in to produce 60 to 65% of your saliva when you are actively stimulated, like when you're eating a meal. The submandibular, on the other hand, is the second largest, but it handles 70% of the baseline everyday background saliva. It's this beautiful division of labor that ensures your mouth is never entirely dry, but it's also ready to just flood with fluid the second a meal arrives. Finally, let's introduce the last and certainly the smallest member of the major salivary gland family. Number 3, the sublingual gland, which is small but mighty.
The name honestly tells you exactly where it is. Sub, meaning under, and lingual, meaning tongue. This gland is quite small, weighing only about 5 grams, and it has a lentiform, or almond-like shape. It sits right behind your lower canine teeth, completely hidden beneath the mucosa of the floor of your mouth. It primarily pumps out a thicker, mucus saliva, contributing just about 5% of your total daily output. But don't let that fool you, it's an essential 5%, providing that slippery, protective coating over your tissues. We've covered a lot of complex anatomical ground today, so let's consolidate this into a simple, memorable recap so you can really lock in this knowledge about your salivary network. So, the crucial point here is that your digestive process relies on a unified network of 3 distinct structures. Number 1, the parotid gland, the heavyweight that kicks into gear when you eat, delivering fluid via Stenson's duct. Number 2, the submandibular gland, your daily baseline workhorse, keeping things lubricated via Wharton's duct. And number 3, the sublingual gland, the small almond-shaped producer sitting right under your tongue, adding that vital mucus coat. And that brings us to the end of our visual breakdown. It's kind of amazing to think that every time you simply crave a slice of pizza, this entire subconscious plumbing network just springs right into action. Understanding our own anatomy gives us such a profound appreciation for the intricate machinery keeping us alive every single second. So, which anatomical system should we simplify next? Let me know in the comments, and make sure to subscribe to The Explainer for more clear, structured, and visually driven medical explanations. Keep learning, and I'll see you next time.